Hello, this is my task 4.3D project for SIT 210 embedded systems. In this project, I am showing how my Arduino Nano 33 IoT handles multiple interrupts and a timer interrupt using a button, light sensor and a DHT22 sensor. Each one controls an LED or prints message in the serial monitor. The main goal is to prove that how my system works in the real time and react quickly in the events. Now, let me show you my hardware setup. This is my hardware setup. My project uses an Arduino Nano 33 IoT. A push button is connected to pin D2. When I press this button, it controls this green LED on pin D6. A light sensor BH1750 is connected to the board using I2C wires STA and SCL. This sensor checks the brightness in the room and it controls this red LED which is on the pin D7. A DHT22 sensor, here you can see, is connected to the pin D5. This sensor reads the temperature and humidity of the room. It controls a green LED which is on the pin D8. Another small sensor is connected to pin D3, but this one doesn't control any LED. It only prints a message in the serial monitor when it triggered. All the components share the same ground line with the Arduino. Each LED also has a resistor connected so that it doesn't get damaged. As you can see, the main purpose of this hardware setup is to show that different sensors and a button can all work together using interrupts and a timer so the system reacts quickly without getting stuck. Now, I am going to explain the main functionality of my code. But before moving further, let's have an eye on my code once. Let's start with the explanation now. The first part is button on pin D2 which controls the green LED on pin D6. The button is linked with an external interrupt which means the Arduino reacts immediately whenever the button is pressed. As soon as I press it, the green LED on pin D6 toggles on and off without any delay. The serial monitor also prints a message confirming the button press. Second part is sensor on D3, which means no LED only message. This sensor is also connected through an external interrupt. When it gets triggered, it doesn't control any LED, but it quickly prints a message in the serial monitor. This shows that the system can handle inputs even if they are not linked to LEDs. The third part is light sensor BH1750 controls the red LED on pin D7. The BH1750 light sensor is managed by a timer interrupt which runs automatically every 2 seconds. The sensor measures the brightness of the surrounding in the lux. If the light level is high, the red LED on pin D7 blinks on for 1 second and the serial monitor shows the lux value with the message enough light. If the light level is low, means darkness, the LED stays off and the serial monitor shows to dark. The last part is DHT22 sensor on pin D5 controls the green LED on D8. The DHT22 sensor is also read using the same timer interrupt every 2 seconds. It collects the temperature and humidity of the room. These values are printed in the serial monitor. For instance, like 30 degrees Celsius, 70% humidity. At the same time, the green LED on pin D8 blinks for 1 second, just to show that a new reading has been taken. So, the overall working is the button interrupt makes the green LED toggle instantly. The sensor on D3 shows a serial message when triggered. The light sensor checks brightness every 2 seconds, controls the red LED, and print lux values. And the last one is DHT22 sensor. Also works every 2 seconds, printing temperature and humidity while blinking green LED. This proves that the code successfully used both external and a timer interrupt to make the system responsive and reliable. Now, I am going to show you the live working of my hardware setup so that you can easily understand and see what happens if all things are working together. First, let's see, this is my BX1750 light sensor which controls this red LED. This is my DHT22 sensor which controls this green LED on pin D8. And here is the push button which controls this green LED which is on the pin D6. Now first our main step is select our board and port and then save it using Ctrl plus S and then compile the code. When the compiling is done, I am going to upload it. After the uploading done, I am going to open the serial monitor and you can see it prints the message that system is ready. Here is our setup. First you can see this green LED change its state because it is connected with the DHT22 sensor and right now this sensor is detecting the temperature and humidity value of the room, and when it gets the value the LED starts on, otherwise it remains off. In between there is a difference of few seconds. This is our DHT22 sensor controls this green LED which is on the pin D8. You can see values on the serial monitor. When it gets the value, the LED is on, otherwise it remains off just for few seconds. Now, this is our BH1750 light sensor. When I put this sensor in the room brightness and when it detects the value more given than the threshold, this red LED change its state, means it start blinking. Blinking is like it will get on when it detects the more brightness than the given threshold, and then when I kept the light sensor into the darkness, the LED is off and it shows the message that too dark. As you can see here, it also displaying the message, which means that right now our light sensor is doesn't detecting any brightness. Let's see now. When I put this sensor up in the light, you can see our red LED is blinking. And when I put it down again in the darkness, our red LEDs doesn't blink. And you can see on the serial monitor message that too dark, red LED stays off. When I put it again in the room brightness, it gives the message that enough light, red LED blinking. Which means that till now our DHT22 sensor and our light sensor BH1750 is working very well. Now the time to check with the push button. When I press the button, you can see message on the serial monitor, button pressed, green LED toggled, and when I press it again, the LED is off. When I press the button and off and again press it, it gives the same message, which is button pressed, green LED toggled. Because this green LED, this green LED is controlled by the push button and the green LED is on the pin D6. When I push the button, it changes state and print the message on the serial monitor, button pressed, green LED toggled. When I again pressed it, it prints the same message, but it changed states now. When I press the button, it it is on now. When I again press it, it is off now. Press first on, then again off, then again on, then again off. From which it is confirmed that our button and our DHT22 sensor and our light sensor, all the three interrupts are working very well, and it is also proof that my Arduino Nano 33 IoT can handle multiple interrupts. Let me show you once again. I press the button, this LED changes its state on and off, and side by side it prints the message on the serial monitor. You can see on the live screen. This LED is controlled by the DHT22 sensor, means when this sensor detects the temperature and the humidity of the room, the LED is blinking, and when it doesn't detect the value, it remains off. In between, there is just a gap of few seconds. That's it. And for the light sensor, when I pick it up and detects the more brightness than the given threshold, then our red LED is blinking. As you can see, our red LED is blinking. And when I keep the sensor in the darkness, our red LED stays off. I push the button, pick the sensor in the room brightness. Which means that our all the interrupts are working very well. In conclusion, in this task, I showed how the Arduino Nano 33 IoT can use both external and timer interrupt to manage different inputs, like the button interrupt toggle the green LED which is on pin D6. The light sensor controlled the red LED, which is on the pin D7, depending on the brightness of the room, and the DHT22 sensor printed temperature and humidity readings while blinking the green LED, which is on the pin D8. This proves that my system can handle multiple sensors and inputs at the same time without delays. It works smoothly and responds quickly, which was the main goal of this task. Thank you.